All right, so chapter 8 starts with like matrices and systems of equations. So we've actually already learned how to solve systems of equations with 3 variables. Now we're going to put it into matrices, and we're going to actually be solving for like 4 variables, 5 variables, that kind of stuff for you, okay? A matrix is just a technique that involves using a rectangular array of numbers, okay? And the definition of a matrix is if m and n are positive integers, then m times n makes in a matrix is a rectangular array where my rows go left and right and my columns go up and down, okay? And each row will represent a system of equations, okay? Will represent one of the equations, okay? Each entry of your matrix is a number. An m times n matrix has m rows by n columns, okay? The dimensions is always m by n, okay? M by n. So we always do, when it asks for dimensions here, we always go by rows by columns. Good morning, Sam. Okay. So in example 1, it's just asking us to say, what is my dimension of my matrix, okay? So we look at how many rows we have, so how many go left to right, and then how many go up and down. So in this case, in A, we have 1 row and 1 column, so this is just a 1 by 1 matrix, okay? In B here, okay, we have 1 row and we have 4 columns in this, so this would be a 1 by 4. Okay, so we always go left to right, then up and down. Okay, C, we have 2 rows and 2 columns, so this would be a 2 by 2 matrix. Okay, and then D, okay, going left to right first, we have 3 rows and we have 2 columns going up and down, so this would be a 3 by 2 matrix. Okay, is everyone okay with dimensions here? Yeah, okay. An augmented matrix is a matrix derived from a system of linear equations, okay? The coefficient matrix is the matrix derived from the coefficients of the system, okay? So in example 2, it says, write the augmented matrix for the system of linear equations. What is the dimensions of the augmented matrix? Okay, so we're just going to take this and we're going to write it as a matrix. Okay, so since we have 4 equations, we're going to have 4 rows. Okay, now how many unknowns do we have? We have an X, we have a Y, we have a Z, and we have a W. W always goes at the end here. We always go X, Y, Z, then W. And then we have our constants, right? Our answers. So we are actually going to have 1, 2, 3, 4, since we have 4 unknowns, and then we have to also have our answer. So we're going to have 5 columns in this sense, okay? So as I look at my first row, the coefficient of X is 1, the coefficient of Y is 3. There's no Z, so the coefficient for Z would be 0. We do have a W, and the coefficient of W is -1. And then we always put like a colon here to represent that the other side is the equal sign. So the colon's kind of like our equal sign, all right? So that would represent our first row, which is my first equation. So again, this is X, Y, Z, W, okay? So the second one, we have no X, so the coefficient of X would be 0. We have a Y, the coefficient is -1. We have a Z, the coefficient is 4. We have a W, the coefficient is 2, and then the equal is -2. Okay. Row 3, third equation, we have an X, the coefficient is 1. We have no Y, so the coefficient would be 0. Z, -5, W, -6, and that equals 0. And then our last one, we have an X, so 2, Y is 4, Z is -3. We have no W, so it'd be 0, and it's equal to 4. Okay. So now as we look at this, we have 4 rows and we have 5 columns. So this is a 4 by 5 matrix, augmented matrix. Okay. All right, any questions so far? All right, let's go ahead and move on. All right, elementary row operations. Okay, so with augmented matrices, okay, when we're looking at any matrix, we can do tons of different things with them. We can multiply rows, we can add rows, we can switch rows, we can divide rows. So in this case, that's just called the elementary row operation. Okay, so we can interchange 2 rows, and the notation for that is like row A, which may be row 1, and we're going to change it. So we do a double arrow or a line with row B. Okay. So that just says we're going to switch row 1 with row 2, and they're just using A and B instead. Okay. We can multiply a row by a non-zero constant. Okay. So I could take any non-zero constant like C and multiply it by any row, and we'll just say row A again, or row 1. And we just have to make sure C is never equal to 0, because if I multiply by 0, what's going to happen to every single one of those numbers? It's going to be 0, so it just cancels everything out, right? Okay. And then we can also add a multiple of a row to another row. So meaning I can multiply a row by any number, and then I can add it to any other row that I want to. So just kind of like we did when we were solving systems and we knew we had to match up the x's. So I was able to multiply the first row by 2. And then multiply the first equation by 2 and then add it to the second one. That's what that represents, except we're just not going to write 2 different matrices. We always wrote 2 different variables, but we're going to do the step together. Okay. All right. So let's kind of practice some of these before we actually get into solving these matrices. Okay. So the first thing I want you to do is to interchange the first and second rows of my original matrix. Okay. So we're going to interchange the first and the second rows. So my new matrix, so if I'm going to interchange row 1 with row 2. Row 3, is row 3 going to change at all? No, row 3 is not going to change anymore. So we're going to leave it as -2, -3, 4, and 1. And now when I interchange these 2, they're just going to switch. So row 2 is now going to become row 1. So -1, 2, 0, and 3. And then row 1 becomes row 2. So 0, 1, 3, and 4. And there you go. That's just how you interchange 2 rows here. Okay. All right, B, let's go ahead and multiply the first row by 1/2. Okay. So here's my original one, and we're going to multiply row 1 by 1/2. Okay. So if I multiply row 1 by 1/2, what's 2 times 1/2? 1. -4 times 1/2 is -2. 6 times 1/2 is 3. -2 times 1/2 is -1. And we've multiplied 1/2 by row 1. It asks us to do nothing with row 2 and row 3. So we're done. We're just going to rewrite it. And there you go. Okay. All right. The next one, we're going to add -2 times the first row to the third row. Okay, so we're going to take -2 times the first row, and then I'm going to add it to the third row. So my third row is what is going to change here. Okay, so my first row is going to stay the same. The second row is staying the same. going to be the third row that changes. And this is where I was talking about that system where we multiply the first equation by -2, write it out, and then we added the equations. That's what we're doing here, except we're just doing it in one step. Okay. So in other words, I'm going to take -2 times row 1. So it's -2 times 1, -2, and then I add it to 2. So -2 times 1 is -2 plus 2 is 0. Okay. Then the next one, same thing. -2 times 2 is -4, and -4 plus 1 is -3. And then the next one, -2 times -4 is 8. 8 plus 5, 8 plus 5 is 13. Okay. And then our last one, -2 times 3 is -6, and -6 plus a -2 is -8. And there you go. Okay. Any questions with that so far?
I actually do have one question.
Yes, ma'am.
So like in example B, where we like were able to multiply and everything, if we were to also like multiply the third row or something by 2, how would we write the notation for that? Would we just put like a comma and put the next one?
Yeah, so right with row 3, we just say 1/2 row 3 next to it too.
Oh, okay.
So
Okay.
that's how we go from this one to that one, is we're changing this row by multiplying by 1/2.
Okay.
So
Okay.
if you notice, that's why I kind of wrote them everywhere by what we're changing with this. Okay.
Okay.
Yep. Good question. All right. So the whole idea with it, what we're doing in this sense, is we want to solve for that X, the Y, and the Z. Okay. And the nice thing that we know, if this is 0, that represents we have no X coordinate. So my X coordinate would disappear, right? Because 0 times X is 0, so I wouldn't have it. So I just have like the Y, the Z, and the equals, right? Our whole goal is to get almost everything equal except for our coefficient here. Our coefficient equals this, because then if I just have Z equals 5, wouldn't we know what Z is? Yeah. So our whole idea is that we want to get zeros, okay? Zeros in this spot, and that spot, if it's a 3 variable system. And that way, if we have zeros in this spot, this would be, we could have Z equals a number. We could have a Y, a Z equals a number. So if I know what Z is, couldn't I plug it in here then to find my Y? And then once I know my Z, my Y, I can then find my X originally, right? So that's the whole idea, is where we're going with this, is we want zeros here. And actually, we're going to go farther, and we're going to want a 1 for every single coefficient here, okay? So that it's easier to solve for when I see 1Z or 1Y. Because if I have 13Z equals -8, that makes it a little bit harder to solve, right? So we want to make these kind of coefficients as 1 and everything else as zeros below it. And we're going to talk about that a little bit more later, but we're going to kind of incorporate it here for a second, okay? All right, so we're going to compare the linear systems and the matrix operations, okay? Now, and I'm just going to do it in the matrix sense. So they went ahead, here's my linear system, and here is the augmented matrix from that, okay? So here's my X, my Y, and my Z, okay? And then obviously my equal, okay? So what we want to do, our goal is to go X is 1. We want the X's to be zeros in the other ones, right? We want 0 to be for the Y in the last one so that we can able to solve for Z, right? So our goal is to make all 3 of these values be 0, okay? Now, we always start with the first 0. We always want to do the first 0 to the left, okay? So if I have -1, okay, we want that to be 0. Could I add -1 to any one of these equations to get to 0? I could add row 1 with row 2, couldn't I? If I add row 1 and row 2, wouldn't I get 0 in that first spot here? Yeah, so I'm going to go ahead and just rewrite my first one for a second. And I always put 2 dots instead of 3 because it's easier. All right, so let's add. 1 plus -1 is 0. -2 plus 3 is 1. 3 plus 0 is 3. And 9 plus -4 is 5. And I'm going to leave the second one. So great, we have that 0 in this spot here. Now we need to do the 0 below it, okay? So if I want 2 to become 0, what would I have to do to equation 1 so that when I add them, they would get to 0? What do you think? If I want to match 1 and 2 up, what would I have to do to equation 1?
Multiply by -2.
Perfect. Yeah. So I'm going to multiply the first equation by -2, and then can I add it to equation 3 at the same time? Yeah. So I'm going to go ahead and just rewrite my first ones for a second. Oh, that should be a 1. I'm sorry. This is a 1. I can't copy. All right. All right. So that's a 1. All right, so let's go ahead and do this. -2 times 1 is -2. -2 plus 2 is 0. Good. Okay. -2 times -2 is 4. 4 plus -5 is -1. -2 times 3 is -6. -6 plus 5 is -1. -2 times 9 is -18, and -18 plus 17 is -1. Okay, is everyone okay with that? Okay. Now, great, we have zeros in the first for x's. Now, if I'm looking for the second row, I want a 0 in my y spot. Why? Because I want to be able to find my z, right? So I want to put a 0 here. So what could I do to, if this is -1, I would have to add that to a +1, right? And do I have a +1 anywhere within this equation? Yeah, row 2, right? So I'm going to go ahead and just add row 2 and row 3 together. That's an R, not a B. All right, so I'm going to rewrite the first one. Rewrite the second one. And I'm going to add row 2 and row 3 together. So 0 plus 0 is 0. 1 plus -1 is 0. 3 plus -1 is 2. And 5 plus -1 is 4. Okay. Is everyone okay with that? Then we want to try to get all of the coefficients to be 1, which it's nice. X is 1 here. Y is 1 here. We need z to be 1. So how could I get z to be 1 here? What do you think? What could I do to that to get to 1? What could I do to that row to get to 1? Remember, row operations say I can add things, I can interchange things, I can multiply things. So what do you think I could do to get to 2 to get to 1?
Multiply by a half.
Yeah, I'm going to multiply row 3 by 1/2. So my first row is going to stay the same. 1, -2, 3, 9. Row 2 is going to stay the same. And row 3, multiply by half. A half times 0, 0. Half times 0, 0. Half times 2 is 1. And a half of 4 is 2. So now we're exactly what we want. We want our coefficients to be 1, and we want zeros in the front there. So now we can actually solve our equation. Because remember the last equation, remember this is x, y, z. So it says z equals 2. So you guys already know what z is. My second equation would be say y plus 3z equals 5. Well, could we solve for z if I know, or can I solve for y if I know what z is? Yeah. So y plus, what's 3 times 2? 6 equals 5. So y equals -1. And then if I know what z and y are, can I use the first equation to find my x? Yeah, because we have x minus 2y plus 3z equals 9. So x, a -2 times -1 is a +2. 3 times 2 is 6 equals 9. And when I solve, I get x is 1. So we know our point of intersection of this is 1, -1, and 2. Okay. So it's not that it's a lot of like that difficult. It's just a lot of thinking a little bit, I think. You guys agree with that? Yeah. All right. The next part of this, but this is mainly what we're doing. So we've kind of already done with the next part, but just a little bit different order. Okay. So row echelon form or reduced row echelon form is a matrix in row echelon has the following properties. Okay. Any rows consisting entirely of zeros occur at the bottom of the matrix. So if I have any rows that have all zeros, it has to be at the bottom of my matrix. If it's not, then it's not in row echelon form, okay? For each row that does not consist entirely of zeros, okay? So if I have a row that does not have all zeros, the first non-zero entry must be 1. So if I see a 0, 0, and a number, that number needs to be 1, okay? For 2 sets of rows, the leading 1 is in the higher row farther to the left than the leading 1 in the lower one. So in other words, your ones need to be diagonal from each other, okay? They need to start upper left going down to lower right. They can't go lower right and go up, all right? They have to go down. So they're going kind of looking at slope, they're going down, okay? My slope of my ones is negative, okay? Now, a matrix in row echelon form is in reduced row echelon form when every column that has a leading 1 has zeros in every position above it and below it, okay? So if we're in row echelon form, okay, to be reduced, wherever I see a 1, I have to have a 0 above it and below it, or no number, okay? So either if it's the first one here, obviously there's not going to be a number before it, but it has to have a 0 below it, okay? All right, so let's kind of look at, are we in row echelon form or reduced row echelon form, okay? Determine whether each, okay. So let's look at A here. Any rows consisting entirely of zeros occur at the bottom. Do I have any row consisting of all zeros in A? No, okay. So we're good in that sense. In 2, for each row that does not consist entirely of zeros, the first non-entry is 1. So I have it 0, 0, 1, we're good. 0, 1, we're good. 1, we're good. So it matches that one too, all right? If it went 0, 0, 2, it wouldn't be, okay? Then for 2 successive rows, the leading 1 is higher, in the higher row is farther to the left than the leading 1 in the right. So do my ones go down in order? Yes. So A is in row echelon. So A is, okay? So let's look at B. Do we have a row entirely of zeros in B? Do we have a row entirely of zeros for B? Yes, we do, right? We have one right here. Is that row at the bottom of my matrix? No. So this is not in row echelon form. Okay. All right, C. Do we have any rows that are all zeros? No, we're good. All right. For each row that does not consist entirely of zeros, the next number is 1. So let's see. That starts with 1. Good. 0, 0, 1. Good. 0, 0, 0, 1. Good. 0, 0, 0, 0, 1. That's good. Okay. Then do my ones, is the row above to the left my ones, or are my ones going down diagonally? Yes, they are. So C is also in row echelon form. Okay. All right, D. Do we have a row entirely of zeros? Yes. Is it at the bottom of my matrix? Yes, it is. So this here is at the bottom. We're good. All right. For each row that does not consist entirely of zeros, the first non-zero entry is 1. So 1, 0, 1, 0, 0, 1. Good. And then zeros. So yes, it is. Okay. And then are my ones going down? Yes. So this would be also in row echelon form. Okay. E, we don't have any rows entirely of zeros. And then we have to go, if we have zeros, the first entry has to be 1. I have 1 here. 0, 2. Is that in row echelon form? Nope. All right. And then F. We have a row of zeros, but it's at the end, so we're good there. 0, 1, 0, 0, 1. Good. And my ones go down, so F is also in row echelon form. Okay. All right. If it is, determine whether it is in reduced row echelon form. Okay. So we got to look at these and see if they're reduced. Okay. To be reduced, remember, wherever we see a 1, above it and below it has to be a 0. Okay. So if I look at the first in A here, 1, this is the highest one, so we only have a 0 below, so that's good. The next one, we need to have a 0 above it and below it. And does that happen? No, that has a 2, so that is not in reduced. Let's go to C. 1, below it is 0. Good. We have a 1 here. Above it is a 2. Below it is a 0. So isn't that in reduced? Nope. D. We have a 1 at the beginning, which is fine. So below it is a 0. Good. The next one, above it is a 0. Below it is a 0. So that's good. The next one, above it's a 0. Below it is a 0. We don't have any more 1s. So this one is good. So D would be in reduced row echelon. And then what do you guys think about F? Our first one is here. We don't have above, but we do have below, and it's 0. Good. And then the second one, above and below, is 0. So F is also in reduced. Okay. All right. Any questions with that? No? Okay, good. All right. Let's look at example 6 now. Okay. So this is what we kind of talked about already. So I'm not going to go through that all. That's what we were doing before. Okay. I should say to find the solution. There you go. All right, so let's go ahead and write our system first. Okay, our augmented matrix actually. So I'm going to start and write. Okay, so we have 4 unknowns. So we're going to go X, Y, Z, and W, and then our answer. Okay, so my X is 0. My Y is 1. My Z is 1. My W is -2. And my equals -3. Row 2, X is 1. Y is 2, Z is -1, W is 0, equals 2. Our third one, X is 2, Y is 4, Z is 1, W is -3, equals -2. And then the last one, 1, -4, -7, -1, -19. Okay. So once again, to make this the easiest for us to do, we know we have 4 unknowns. So the easiest way is to get 1s in the diagonal, right? So 1's in the diagonal. And everything before it needs to be zeros, right? So our coefficients of our variables are going to be 1's. And the coefficients, all these pink ones, the numbers before where we want need to be 0, okay? So what I'm going to look at first is let's go ahead and start with the first upper left corner. We want that to be a 1. So could I either A, interchange some rows to get that to be 1, or do I have to add it to something to get to 1? So I want my first X coefficient to be 1 here. So could I just interchange the first 2 rows to get that to be 1? Yeah, so let's go ahead and just interchange my first 2 rows. So row 1 is going to change with row 2. Okay, so 1, 2, -1, 0, 2, then 0, 1, 1, -2, -3, and then 2 and or 3 and 4 are going to stay. Okay. All right, is everyone okay with that? Now, as we did that, something nice happened where we got our 1. We also got 0 for my X in the second equation, and we got 1 for my coefficient there, right? Now we need to turn this number to a 0. Okay, so we want to make 2 become 0. So if I want this to become 0, what could I do with a row above it to get that to 0? If I want 2 to become 0, I need one of the numbers above it needs to be -2, correct? Okay, so when I multiply row 1 by -2 and add it to row 3, would that make sense? Are we okay with that? All right, so let's go ahead. So for row 3, I'm going to multiply row 1 by -2, and I'm going to add it to row 3. You guys okay with that? All right, so I'm going to rewrite the first one and the second one. 1, 0, 2, 1, -1, 1, 0, -2, 2, -3. All right. Now, what is -2 times 1 is -2. -2 plus 2 is 0. We're good there. -2 times 2 is -4. -4 times 4 is 0. -2 times -1 is 2. 2 plus 1 is 3. -2 times 0, 0, plus -3 is -3. And -2 times 2 is -4. -4 plus -2 is -6. Okay, is everyone okay with that? And then I could go ahead and write the next row, but I'm gonna, so I don't have to do so many, I'm gonna go ahead and do a same step here, okay? We need this also to be 1, right? Or excuse me, needs that one to be 0, correct? So since it's 1, what could I do to row 1 again to get this to be 0? Couldn't I multiply row 1 by -1 and then add it to row 4? Would that be okay? Yeah, so let's go ahead and do that again. So -1 times 1 is -1, plus 1 is 0. -1 times 2 is -2, plus -4 is -2, plus -4 is -6. Okay. I don't know why I had problems there. -1 times -1 is 1. 1 plus -7 is -6. 0 times -1 is 0, plus -1 is -1. -1 times 2 is -2, plus -19 is -21. Okay, great. Is everyone okay with that? Okay, so now we have our 1 here, which is good. We have 0, 1, awesome. We have 0, 0, which is great. We need to turn this to a 1, but we also need a 0 here, right? And a 0 there. So let's do this 0 first, because we always have to work from left to right, okay? So I want this -6 to be a 0, right? So what could I do to row? We can either do row 1 or row 2. Okay, and I'm going to choose, and the reason why here, I'm not going to multiply by row 1 in this sense, because if I multiply by row 1 and add it to 1, am I going to, or add it to 0, am I going to keep that 0 in that spot? No. So I want to make sure I always keep 0 in this first one. So I'm going to now only multiply by row 2 or row 3, because we want to keep that 0 when we add, okay? So, and obviously row 3 has a 0. So I need to multiply row 2 by something. And what would I multiply row 2 by? Since I have -6, I'm going to multiply it by a
Positive 6.
Yeah, exactly. Thank you. So we're going to go for that last row. I'm going to multiply row 2 by 6 and then add it to row 4. Okay. So I have 1, 2, -1, 0, 2, 0, 1, 1, -2, -3, 0, 0, 3, -3, -6. All right, now let's multiply. 6 times 0, 0, plus 0, 0. Good. 6 times 1 is 6. 6 plus -6 is 0. Good. 6 times 1 is 6. 6 plus -6 is 0 again. Ooh, that's nice. 6 times -2 is -12. -12 plus 1 is -13. 6 times -3 is -18. -18 plus -21 is -39. There you go. Okay. So now we have 1, 0, 1, 0, 0, and not 1. 0, 0, 0, not 1. So we're almost done. Okay, you guys have done a really good job with this, where we have zeros and everything. We need this to be 1, and we need this to be 1. So if I look at 3, -3, and -6, what could I do with that entire row to get to 1 there? What do you think? Could I just multiply row 3 by 1/3, which is the same thing as dividing by 3? Couldn't I divide by 3 to get to 1? And then could I, for that last one, could I divide by -13 to get to 1? So wouldn't it be the same thing as multiply by -1/13? For some reason, when we do this, you have to multiply. So instead of saying dividing it, you multiply by the fraction of it, okay? But same idea. So first and second row is staying. And then we have 0, 0. All right, so now 3 divided by 3 is 1. -3 divided by 3 is -1. -6 divided by 3 is -2. And then we have 0, 0, 0. -13 divided by -13 is 1. And -39 divided by -13 is 3. So now we have, let's look at this. We have 1, 0, 1, 0, 0, 1, 0, 0, 0, 1. We're exactly where we need to be. So this last row tells me what Z equals, or Scott, not Z, W equals. And what does W equal? W will equal 3, right? The second equation, it says Z minus Y, or W, equals -2. So Z minus W equals -2. Well, W is 3, right? So Z minus 3 equals -2. So Z equals, add the 3, 1. You guys okay with that? Then the next one says y plus z minus 2w equals -3. Well, we know z is 1, w is 3, so 2 times 3 is 6, so -6 equals -3. So we get y minus 5 equals -3, so y equals 2. Okay. And then the last one, we have x plus 2y minus z, there's no w, equals 2. So x plus 2 times 2 is 4, minus z, which is 1, equals 2. So x plus 3 equals 2. So x equals -1. So we know x is -1, y is 2, z is 1, and w is 3. And there you go. Okay. Any questions? All right. Let's flip it over. Just a couple more examples here. Okay. All righty. So looking at this one, okay, we're going to do the exact same thing we just did here. Okay. So writing my fraction. Okay. So we only have 3 unknowns. Okay. But we have, in this case, we have 3 unknowns, but we have 4 equations, don't we? So we're going to have 4 rows, okay, and 4 columns. So 1, -1, 2, 4, 1, 0, 1, 6, 2, -3, 5, 4, and then 3, 2, -1, and 1. Okay. So as we do this again, okay, and we always have to look, we want 1 down my columns, right? And if you notice, the last one we don't have, right? But that's our whole goal, is we want to get 1s in the diagonals and we want 0s in all the other places, right? Okay. So let's start with, we have 1 in the first one. Let's get the second one to be 0. So what would to get to my second one to be 0, couldn't I just multiply row 1 by -1 and add it to row 2? You guys okay with that? So I'm going to rewrite my first one here. So 1, -1, 2, and 4. Okay. So -1, negative times 1 is -1, plus 1 is 0. -1 times -1 is 1. 1 plus 0 is 1. Negative times 2 is -2, plus 1 is -1. Negative times 4 is -4, plus 6 is 2. Okay. All right, so we're done there. Now I'm going to go ahead and keep going, if you don't mind, on the same row here. If I want to make this 2, what could I do to row 1 still to get this to 0? Could I multiply row 1 by -2 this time and then add it with row 2 or row 3? Sorry, row 3. Yeah. So just so that we don't have as much steps here. Okay. So -1 or -2 times 1, -2, plus 2 is 0. -2 times -1 is 2, plus -3 is -1. -2 times 2 is -4, plus 5 is 1. -2 times 4 is -8. -8 plus 4 is -4. And then the last one, I want to get that 3 to 0. So could I now multiply row 1 by -3 and add it to row 4 still too? Yeah. So -3 times 1, -3 plus 3 is 0. -3 times -1 is 3, plus 2 is 5. -3 times 2 is -6, plus 1 is -7. And then -3 times 4 is -12. -12 plus 1 is -11. Okay. All right. So now we have 1 in the first, 0s below, which is nice. We have 1 in the diagonals, but now we need to make this a 0 and this one a 0, right? okay? So let's go ahead and get the first one to 0. If I look at -1, couldn't I just add that with row 2 to get to 0? Yeah. So I'm going to go ahead. Row 1 is going to stay the same. Row 2 is staying the same. Row 3 is what's changing, and we're going to add row 2 with row 3 here, okay? So 0 and 0 is 0. 1 and -1 is 0. -1 and 1 is 0. 2 and -2, or 2 and -4 is -2. Huh. What do you guys notice right there? What do we notice? Do we have any variables left? No. And if I don't have any variables left, can I have a solution? No, not really, right? In this case, there's no variables. So does 0 equal -2? No. So we have no solution for this. We have no solution. Now we can go ahead. I'm going to rewrite the last equation. But yeah, we actually have no solution because there's no variable in this equation, right? So my new system, if I look at this, would have been like x minus y plus 2z equals 4. Y minus z equals 2. 0 equals -2. And then we have 5y minus 7z equals -11. Well, this can't happen, can it? So that's why it is no solution in that sense. Okay? All right. All right. Gauss-Jordan elimination is what it does is exactly what we're doing. The only difference is that it takes it a little bit farther and makes it into reduced row echelon form, meaning you have zeros above and below those coefficients. Okay. So like if I'm looking at this one here, obviously from this, if here's a 1, I need to have a 0 in the numerator and in the top, and I have to have a 0 in the denominator. So this, all it does is just takes it one step farther. Now you don't have, you can do it from here to solve your equations like we did, or you can go farther so that you just have x equals this, y equals this, z equals this, and you don't even have to solve anything. So we're going to do one example in that sense here. Okay. All right. So let's go ahead and write our equation, our augmented matrix. So we have 1, -2, 3, 9, -1, 3, 0, -4, 2, -5, 5, and 17. Okay. All right. So once again, it's nice. We need to have 1 here. We're going to have 1 in all of the diagonals. And I want to have zeros in every other spot. That's what the Jordan, our Gauss-Jordan elimination is. Okay, so we want 1s in the diagonal and then zeros everywhere else. Okay, now we always tend to work our zeros from left to right. Okay, make it easier. So if I want to make this one a 0 first, how could I get that to 0?
Add it with the first row.
Yep, exactly. So we're going to add the first and second row. So we have 1, -2, 3, and 9. 1 and -1 is 0. 2 and 3 is 1. 3 and 0 is 3. 9 and -4 is 5. Okay. And then we could, if you want, go ahead and do the same thing for here, right? Go ahead and do it the same, or we can wait if you want. Okay. Do you guys want to go ahead and just, here, I'll just go ahead and rewrite, sorry. So now we need to get 0 in this spot, right? So what would I do in that sense to get 0 in that spot? How could I get 0 in that spot at 2?
Multiply the top by a -2 and then add them.
Yep. So I'm going to multiply the first one by -2 and add it to row 3. So 1, -2, 3, 9, 0, 1, 3, and 5. Okay. All right, so -1 times 2 is -2 times 2 is 0. -2 times -2 is 4. 4 plus 5 is -1. -2 times 3 is -6. -6 plus 5 is -1. -2 times 9 is -18. -18 plus 17 is -1. Okay. You guys good with that? Okay. Now we have 1, 1, okay, which is good. We have 0 and 0. Now we need to start here and we need zeros in these two spots, right? How could I get 0 in the first spot? How could I get a 0 in the first spot? Okay. All right, let's do the bottom one first. How's this? Make it easier. Isn't this 1 and -1? Couldn't I just add the second and third row right now? Yeah, let's go ahead and just add the second and third row. Because you guys can see 1, -1, that's easy, right? So 0, 0, 1. 1 plus -1 is 0. 3 plus -1 is 2. And then 5 plus -1 is 4. Okay. All right, you guys okay with that?
Yeah.
Right. Now, to get this to -2, right? Wouldn't I have to multiply the second, or to get -2 to 0, wouldn't I have to multiply the second row by a +2? So to get the first row, I could just multiply 2 by row 2 and then add it to row 1. Are you guys okay with that? Because 2 times 0 is 0. 0 plus 1 is 1. So that's still staying 1. 2 times 1 is 2. 2 plus -2 is 0. 2 times 3 is 6. 6 plus 3 is 9. 2 times 5 is 10. 10 plus 9 is 19. Okay. You guys okay with that? All right. So now we have ones and we have 0 so far here. So these two rows are done. Let's go ahead and make this 2 a 1 first. How could I make that 2 a 1? How could I make this 2 a 1? Could I just multiply by 1/2 to get that to 1? Yeah, so I can multiply 1/2 by row 3 to make that 1, right? I'm keeping the same. So 1/2 of 2 is 1, and 1/2 of 4 is 2. So right off the bat, you guys know z equals 2, don't you? Yeah, okay, z equals 2. Now we need to get this to be 0 and that to be 0, right? Okay. Now, if I'm looking at this, okay, to get the first one to 0, okay, how would I get 9 to 0? Remember, we want to make sure we keep the zeros in the front and the 1. So we always have to use the last row now because it has 0, 0 in that sense, right? So that won't change anything. But how would I change a 1 to get it to be able to add to 9 to get it to 0?
Multiply by -9.
Yep. So I'm going to multiply row 3 by -9 and then add it to row 1. You guys okay with that? Okay. So 9 times 0 is 0. plus 1 is still 1. 9 times 0 plus 0 is still 0. Negative 9 times 1 is negative 9. Negative 9 plus 9 is 0. Negative 9 times 2 is negative 18. Negative 18 plus 19 is 1. So guess what, guys? X equals what? 1. Because y is gone, z is gone. Now we need this 3 to be 0. So what do I have to do with row 3 again? I'm going to have to multiply row 3 by a negative 3 and add it to row 2, right? You guys okay with that? So negative 3 times 0 is 0, plus 1 is 0. Negative 3 times 0 is 0, plus 1 is 1. Negative 3 times 1 is negative 3. Negative 3 plus 3 is 0. Negative 3 times 2 is negative 6, plus 5 is negative 1. So guess what, guys? You know what y equals negative 1. And then we already did our z is 2. So do we have our point of intersection here? Yeah, we have 1, negative 1, and 2. There you go. Okay. So I don't think it's very difficult. I think it's just a lot of thinking on how do I multiply and how do I add to get to 0 all the time, because you're adding steps together at one time. Okay. But this way is kind of nice, getting all the zeros everywhere, because then you could just say what x, y, and z equals right off the bat. Okay, within that. Now, the last example I want to do is when you look at a problem, you have 3 unknowns, but you only have 2 equations. Okay, that makes it a little more challenging in this sense, right? We have 3 unknowns, only 2 equations. Okay, so if we look at this sense, okay, so we're going to kind of go in the same idea. Okay, so we have 2, 4, negative 2, 0, 3, 5, 0, and 1. As we look at this, we can't get ones in every single diagonal, can we? No, because we could get a 1 here, we could get a 1 here, so we can get our coefficient of x to be 1, our coefficient of y to be 1, but we will never, ever, ever get z to find out what z is, will we? No. So in these types of problems, we're always going to assume z equals a. We're going to let z equal a every single time. Okay. Now, we still need to do what we've done before, where we get 1s in the coefficient for x and y, and we get 0s around it. So we need this to become a 0, the 2 to become a 1. Okay. Now let's get 2 to 1 first, because that's what we should always start with. Okay. Get the first coefficient to be 1. Now, I could multiply both of these to add, to eliminate all that. But what do you notice about all of these values here?
They're multiples of 2.
They're multiples of 2. So could I take 1/2 times row 1 to get 1? Yeah. So 2 divided by 2 is 1. 4, 2, negative 1, 0. And then I'm going to leave the second one. All right. Now we need to get that 3 to be 0, right? We need to get that 3 to be 0. So if I want this 3 to be 0, I would have to multiply the first equation by negative 3 and add it to the second equation, right? You guys okay with that? So I'm going to have 1, 2, negative 1, 0. Then for the second one, negative 3 times 1 is negative 3. Negative 3 plus 3 is 0. Good. Negative 3 times 2 is negative 6. Negative 6 plus 5 is negative 1. Negative 3 times negative 1 is 3. 3 plus 0 is 3. Negative 3 times 0, 0 plus 1 is 1. Okay, you guys all okay with that? So we have 1 in the coefficient. Now we just need this one to be a positive 1. If I want this to be a positive 1, what's going to happen here? I'm just going to multiply that second equation by negative 1, right? You guys okay with that? So that first equation would be 1 2, -1, 0. And if I multiply the second one by -1, that's going to be a +1, a -3, and a +1. Are you guys okay with that? And you can't see that. There you go. All right. So now there's nothing else we can do right now. We could try to get the first one to be, 0 here, but it's still not going to help us because we still don't have our z, okay? So I'm going to go ahead from here. I am going to write our equations, okay? So the second equation here, there's no x, but we have a y minus 3z equals 1. And then we have x plus 2y minus 1z equals 0. Are you guys okay with that? Okay. Now, from here, okay, what did I tell you we're going to let z equal no matter what? Because we can't find z here. So what are we going to say z equals? Z equals a, right? Z equals a in this sense, okay? So since z equals a, could I find y? I should be able to find y because y minus 3 times z, well, what's my z? A equals 1, right? Well, how do I move this 3a to the other side? I add it, right? So isn't y just 3a plus 1? Yeah. So now I know z is a, y is 3a plus 1, and now we have to find our x. So we have our x plus 2 times my y minus my z equals 0. Well, what's my y? 3a plus 1. And what's my z? A, right? So let's just solve for x. 3 times 2a is 6a. 2 times 1 is 2 minus a equals 0. And we have x plus 6a minus a is 5a plus 2 equals x. Oh, plus x equals 0. Now, how would I move 5a and 2 to the other side? Wouldn't I subtract them? So x would just equal negative 5a minus 2. So we know what x, y, and z are. So my x is negative 5a minus 2, comma, y is 3a plus 1, and my z is a. Okay. So if you saw that on your review guide last class on number 6, which I didn't put it on your test, but because we didn't do any of these, but that's what happens where you have 3 unknowns and only 2 equations. Well, we can't really solve for it. So that's why I always say z is a, and then you find what x and y are using a for z. Okay. All righty. And that is it.